Alright, question B. If dy over dx equals to cos 2x and y equals to 1 when x equals to pi over 2, find the value of y when x equals to pi over 4. Alright, so now we're just going to integrate to find our original function, and then we can plug in our initial value, y equals to 1 and x equals to pi over 12, and we can find our c value, and then we can find our value of y. So cos integrates to sine. Okay, so the integral of cos 2x. So this equals to 1 over 2 because we divide by the differentiation of 2x, which is 2. So we divide by 2, it gives us 1/2 sine of 2x plus c. We know y equals to 1 when x equals to pi over 2, so it equals to 1/2 of sine of pi over 6 plus c. Alright, so we get a calculator. Sine pi over 6 is 1/2, so this equals to 1/2 plus c. So therefore c equals to 1/2. So therefore y equals to 1/2 of sine of 2x plus 1/2. And therefore y of pi over 4 equals to 1 over 2 sine of pi over 2 plus 1 over 2. That gives us an answer of 3 over 2, which is our final answer for this question, okay? And this should be an achieved level question. Question C. An object originally moving at a constant velocity suddenly starts to accelerate. From the start of the object's acceleration, the motion of the object can be modeled by the differential equation dv over dt equals to t plus e to the power of 0.2t, 4t is between 0 and 15. V is the velocity in meters per second, and time is the time in seconds when the object starts to accelerate. When t equals to 0, the velocity of the object was 8 meters per second. Find the velocity of the object when t equals to 10. Alright, so to find the velocity function, just what we have how is rate of change of velocity, so this is the acceleration of the motion. To find the velocity function, we need to integrate. So velocity with respect to time equals to integral of t plus e to the power of 0.2t dt. So this gives us t squared over 2. And for e to the power of 0.2t, we need to divide by the derivative of the power. The derivative of the power of 0.2t, the derivative of 0.2t is 0.2. So we need to divide by 0.2. So this gives us 5. So 1 over 0.2 is 5. And the e to the power of 0.2 stays the same. So, e to the power of 0.2t stays the same. And don't forget the constant of integration. So when t equals to 0, v equals to 8. So therefore 8 equals to 0 squared over 2 plus 5e to the power of 0 plus c. So therefore you can see that c equals to 3 because e to the power of 0 is 1. V of t equals to t squared over 2 plus 5e to the power of 0.2t plus 3. So if we substitute v equals to t equals to 10 to find the velocity, v of 10 equals to 100 over 2 plus 5e to the power of 2 plus 3. And that gives us an answer of 89.95 meters per second. And that's our final answer, and this should be a merit level question. To get an achieved, if you can find the correct integral and find the correct c value, you should get an achieved. In radioactive decay, the rate at which the radioactive substance decays at any instant is proportional to the number of radioactive atoms present at that instant. This can be modeled by the differential equation dN over dt equals to Kn, where n is the number of radioactive atoms present and t is the time in days. A quantity of manganese 52 is produced. Manganese 52 is a radioactive isotope of manganese. Manganese 52 has a half-life of 5.6 days. After 5.6 days, half of the atoms of manganese 52 would have decayed. So this is a separable differential equation, so we're going to separate the variables. So we have one, so if we divide n on both sides, we'll have 1 over n dn equals to the integral of k dt. And this should give us ln of n equals to kt plus c. And therefore n equals to aekt. So for this plus c, this is just a constant. So instead of writing plus c, when I take when I take the e to the power on both sides, then I'll just make it a times e to the power of kt, where a represents the constant. So n equals to ae kt. So in this type of formula, okay, so a is actually the original amount of, in this case, original amount of atoms present. So original atoms present is a. But we don't actually know the amount of atoms, the radioactive atoms present. We actually don't know how many, but that's okay. We can figure this one out. So we know that after 5.6 days, we know that a over 2 amount of atoms have been decayed, because half of the atoms have decayed, half of a has decayed. So we can use this to find our k value. So in this case, our n is how much atoms is left, is a over 2. That equals to a times e to the power of 5.6k. So 1/2 equals to, if we divide a on both sides, 1/2 equals to e to the power of 5.6k. So ln of 0.5 equals to 5.6k. So this would give us a k equals to negative 0.12378. And therefore, we can say n is equal to a e to the power of negative 0.12378 times t. So for 95% of the manganese to decay, that means there's only 5% of manganese left. So 5% can be represented as 1 over 20. So in this case, we can say that a over 20, so 5% of the original amount is left. That equals to the original amount left times e to the power of negative 0.12738 times t. So once again, we can cancel out a. So 1 over 20 equals to e to the power of negative 0.12738 t. ln of 1 over 20 equals to negative 0.12378 t. So that should give us an answer of t equals to 24.2 days. So that's our final answer for this question, and this should be a merit level question. To get an achieved, we can find the k value correctly. That should be an achieved. Question E, the graph below shows the curve y equals to cos of x and y equals to cos to the power 3 of x for x is between pi over 2 and 0. Find the shaded area. Alright, so the shaded area can be seen as the graph of y equals to cos x, the area underneath it from pi over to 2 to pi, from x equals to pi over 2 to x equals to 0, minus the area underneath the graph of cos to the power of 3x from x equals to pi over 2 to x equals to 0. So first we can immediately write out our area formula. So that's the integral from x equals to pi over 2 of cos x minus cos 3 of x dx. So we can rewrite this one as, we can separate these ones out. Okay, so we can write it as this. Alright, so in terms of integrating cos, it's very easy. So cos just goes directly back to sine, so we can just ignore that one for now. So in terms of the integral of cos power 3 dx from pi over 2 to 0, we can rewrite cos to the power 3 of x as cos squared of x times cos of x. So we also know that cos x to the power of 2, so cos power of x2, that equals to 1 minus sine, what am I doing? Okay, so cos squared of x, that equals to 1 minus sine squared of x, okay? So we can plug this one in, so we can say that 1 minus sine squared of x multiplied by cos of x dx. So as we can see here, cos is a differentiation of sine. So in this case, we can actually say let sine of x be u. So therefore, du over dx equals to cos of x, and therefore dx equals to du over cos of x. So this will just give us the integral of 1 minus u squared times cos of x over cos of x du. So this gives us integral of 1 minus u squared du, and this gives us u minus u to the power of 3 over 3 plus c. So this gives us u is sine of x, so this gives us sine x minus sine to the power of 3x over 3 plus c. Alright, so now we have those integrals. We can write out our area formula. So area equals to sine of x between pi over 2 and 0 minus sine of x minus sine to the power of 3x over 3 from pi over 2 to 0. So this gives us 1 minus of sine. So 1 minus of sine to the power of 3. So minus 1 over 3 there. Alright, so therefore we should get 1 minus 2 over 3, which equals to 1 over 3 units squared. 1 over 3 units squared, that's our final answer for this question. This is an excellent level question. To get a merit level grade, you should be able to find the integral of both of them. So find the integral here and find the integral of cos of x. That's going to give you a merit. To get an achieved, if you can just find, for example, the integral of cos of x, that could get you an achieved. I'm not too sure. That could get you an achieved. And that's that. So thank you for watching this video. I hope you enjoyed this video, and I hope to see you all in the next